But the idea behind this presentation came from the internal discussions in the SciOS Knowledge Center. And we had references in discussions to EOSC, data spaces, data lakes, digital twins, and a number of other things. And there was a wish to just have a brief tour on some of the concepts. And some of the concepts I would like to briefly touch in this presentation is EOSC, its destination Earth, its digital twins, data space, and data lake. This could have been mentioned in the opposite direction, but I think I will go through it this way just to give us some sort of an understanding of the world outside of SciOS. I also did include one of these bingos on the right-hand side in the slide here. And as we go through some of these concepts, you will probably find this relevant because many of these ones are quite high-level approaches to sharing data or working with data. So first of all, the EOSC. What is the European Open Science Cloud? I think the brief comment to that is that it is a cloud that is not a cloud, at least according to the organizers of EOSC or the community that has worked with it. But it's an open and trusted multidisciplinary environment where people can publish, find, and reuse data, but also tools and services for research and innovation. So it's supposed to be a tool for the research community. And one of the challenges we do have today is that there's a lot of funding from EU, but also from the nations in Europe going into the European Open Science Cloud. And it's underutilized by the science community. So at least I know from Norway, and this is probably elsewhere as well, there is a wish for a larger user uptake of EOSC services among those actually funding the development of it. And there is a focus in EOSC for access for researchers, also individuals or humans, but also machines or computers. So the machine actionable approach that Luke mentioned earlier. And then it's about the machine actionable research data, but also other research or digital objects. And a digital object in this context, as I mentioned earlier, it's a data set. It can be a digital object, but also a software component or information about data and software. For example, embedded into something called a research object crate. But that's, again, I haven't dug into the details about that, and it's too long for this short presentation. The focus of EOSC is interoperability across disciplines. And I think for SciOS, first of all, it's a potential platform for analysis of data, so we should relate to it somehow. Another thing is there's a lot of funding coming through the European system on working on developing EOSC. And for SciOS, the primary collaboration has been through the collaboration of the European Research Infrastructures, or the ENRI community. So if you want to read more about it, you can read through the documents of European Open Science Cloud, both go directly to the EOSC website, but also to the European Commission, and there is a lot of information in there. And you will probably have a bingo immediately on the concepts and the high-level documentation. But the idea is to make it a useful tool for the research community. So please go and check it and see if there's something we could do on integrating with this. Another thing to mention is Destination Earth. And that brings us into the concept of digital twins. We will come a bit back to, but this is a Central European service. It's a collaboration between the three big E's in Europe. It's about ESA, it's ESMWF and EUMETSAT together. Also with now somehow collaborating with Mercator Ocean International. And it's to develop a highly accurate digital model of the Earth. And there's a lot of information available on this concept. It's not something we can directly get involved into. It's actually contracts with the three big E's that are developing this. But the relevance for SciOS is that this is a potential consumer of the data produced in SciOS, because in order to run a digital model or as a numerical model or some other thing, you need data to connect it to reality. And there are now 2 digital twins within the destination Earth. It's one for weather-induced extremes and another one for climate adaptation. And in particular, the last one should probably be relevant for SciOS. The status for the time being is that there are several digital twins. You have 3 components in here. You have a digital twin, you have a data lake, and you have a service platform where you can actually access the data and produce output that you can from these data that you can integrate into your own workflows. So again, there is a link into further explanation of the destination Earth, and in particular the engines of the destination Earth. And then we come to the concept of digital twins. So if you look into the internet, you will find that it's basically a digital representation of a physical object, system or process, linked with observations of the features represented. Or in the words of the environmental community, it's a numerical model or an AI model or something like that. It can be any model for that sake, but it's a representation of the reality around us. It can be used for continuous monitoring, simulation, and analysis of the reality, but it has to be connected to the reality through observations. And the thing that really distinguishes a digital twin from an ordinary numerical model that we have known for decades is basically the direct link between the data and the model. So while we've always, for example, in the meteorological community and also in oceanography, we've connected the models to the observations for decades, this is now integrated into one system. So you have a framework around the digital twin, which actually connects data and the modeling entity in there. So relevance again for SciOS, I do think there are actually digital twin efforts in the context of SciOS or linked with SciOS. But for SciOS, it can be a consumer of the data produced. It can also be a tool for research. So it's actually have some, it's an analytical tool that we can use in order to understand our surroundings better. Data space is the next thing. And data space is a concept that actually originates back to 2005, and it came from the industry. I won't go into all the details. I will end the discussion or the presentation with a relevance for SciOS here a bit, and there will also be a more detailed presentation after the break by Marta Guterres from EGI that is also working on data spaces. So she will give a more thorough introduction to data spaces. But as it says here, data spaces need to identify common standards, including semantics and interoperability protocols, but it goes beyond the interoperability at the technological and semantic level. It also goes into the legal interoperability. And that's why I relate this a bit to the SciOS data management system, which basically is an approach towards a data space. And for data spaces, I think the key is the standardization and semantic annotation, as well as the governance part. So the combination of all those 3. And there is a link for more information if you want to, but I would direct people to the presentation of Marta after the break. And then we do have a data lake. A data lake is a centralized, scalable data repository storing raw, unstructured, semi-structured, and structured data. Data lakes are interpreted very differently by many communities. Some have a focus on the raw data, others have a focus on harmonized data. and making the data easily available for the analysis that people want to do. But again, the key is the governance, metadata management, and curation. So if you put all the data you have into a sort of a central repository without governance, without metadata, you do not have a data lake, you have a data swamp, basically. So you have a lot of data, you're wasting energy on storing the data, but you can't do much without it. So perhaps there's a good way to rethink how we think about the concept of data lake. And the relevance for SIOS here is that it could be used for analysis. So it could be sort of a staging area where we go from a data space and into a data lake, making it easy to work with the data. And this is where we could link it with things like the European Open Science Cloud as a platform for research that is actually funded by the European community. And this is my final slide, and it's basically just to show that the evolution, so it's the evolution of the SIOS data management system. So we did have the preparatory phase where we had the development of the ID of the SIOS data management system. We went from a centralized repository into a distributed system. We identified some of the functionality that we wanted: data submission, data discovery, data access, data transformation, and long-term preservation of data sets. Through the interim phase, where we actually developed data policy, a data management plan, an implementation plan for the SDMS, interoperability guidelines in the first versions, operations manual, KPI documents. At this step, we actually started to move towards a data space for SIOS. And then in the operational phase, in the practical implementation, we've actually moved further on into the governance documents. We've refined the documents from the interim phase, but we've also added perspectives on granularity, on the harmonization of SIOS core data, etc. So through the phase here, you see that SIOS has moved from basically like an idea of a data lake, more or less, towards the idea or the concept of a data space. And the challenge we do have is when or will we reach a fully implemented SDMS that is relevant? So how can we make SIOS relevant at a larger scale? So how do we make it relevant in the Arctic, but also in Europe, since there is so much funding going into the joint data activities in Europe? And the final statement is that a data space governance is the main limiting factor. So you can have the interoperability outlined, but if it's not implemented by the data providers and the data repositories contributing, then we don't have a working data space. And what is needed in order to build services that Luke identified or showed is not necessarily what the users want, but that intermediate step is highly necessary in order to provide what the users want in the end. So the flexibility on the user side. And the idea now is perhaps addressing analysis through a data lake adapter, so not necessarily a data lake, but a mechanism that allows people to download the relevant data, perhaps link it with software, and stage data for processing in the European Open Science Cloud or in a local research environment. For example, in Poland, I know they've been developing a processing environment as well. This we could do using a research object, Freight. But that's for another presentation, if so. Thank you.